A little bit about the content. I will start by going through a little bit the design philosophy behind the concept, describe the ship, and then go on to look a little bit at environmental considerations and the aspects of using LNG as a marine fuel. Then I will benchmark that concept and the fuel choice to see if we can, how it compares against the other options in the market. And then some propulsion and concluding remarks after that. If you look at the design philosophy, what we have tried to do, we have designed a contemporary cruise ship for emerging markets. We have put it, as we call it, handy size. That means that it's medium in size. It's 65,000 gross tonnage, 1,560 passengers, lower beds. And the reason for selecting this size is we want it large enough to give good economy of scale, but still small enough to be able to enter small ports and have a low enough investment cost to allow easier financing. And one of the features, of course, that we want it to be environmentally friendly, and that we have approached by going to LNG. So, handy size is what we want to be able to sell it as for upcoming markets that are not big enough to fill a post-Panama ship, but also possibility to enter small ports and give a nice atmosphere on the ship. On the other hand, a really small ship would not be able to offer all the nice features that the passengers are looking for today. So we are in the medium size. Here you see the small luxury are smaller, Panamax and post-Panama are bigger, but we try to position us here in the handy size region. Yeah. On the machinery side, which is one of the main features of this concept, we have gone for an environmentally friendly solution and a very efficient and low power demand as well. So we have gone with LNG, dual fuel engines, and it should be IMO Tier 3 compliant. And power demand we have tried to reduce by having efficient machinery, energopacrados, low loss electrical concept, but also a modest speed on it. If you look at the design in itself, we have made the hull a little bit wider than normal for a ship of this size, 34 meters. Better stability, we can build a higher superstructure, and we get a lot of balcony cabins. It's also a very simple and uniform type of superstructure that should be afford some good cost savings in the building and construction phase. As mentioned, we made the ship a little bit wider, and we try to utilize the benefits of the new Panama Canal locks that will be introduced shortly. And they will open in 2015, so really it's high time to start designing the ships according to these new locks and not limit yourself by the narrow old canal. You see the main dimensions, I will not dwell on that, but you see 65,000 gross tonnage, that's the main feature, and then the lower berth, 1,560. Some features of the ship, mentioned wide hull, but we have even extended the promenade deck even wider to give a nice outdoor deck areas. And then we have put bigger lifeboats to have fewer of them, not to block the view from the ship, and a pool deck aft of the ship. We have extended the hull to give a nice pool deck there. And here you see some of the features. It's lower down, so we can have a very large pool. That's one of the nice benefits of this concept. We have an artificial beach and some water slides there. On the upper decks, we have a pool with a more relaxing and calm atmosphere for the more senior passengers looking for that type of area. And we also have the spa and gym there. Otherwise conventional, we have the show lounge in the forward part, main restaurant aft, but we have the wide panorama decks. That's one of the features here. You see how wide they are, and you really can get a lot nice features there. And then maybe these outcoming small arcade type of windows there, which give a lot of natural lights into the ship, and so on. But another feature you might have noticed is that we put the fast tender boats here in the stern, and the idea with them is that we can provide some extra itineraries on this, extra destination ports. So part of the passengers can jump into these fast 30-knot tender boats and go to even smaller ports that cannot accommodate the cruise ship at all. Or you can just select what type of city or destination interests you the more and select from there as a passenger. So you might have a wider appeal to the market as a cruise ship provider. Yeah. On the environmental side, if you look at this, you can say that the ship owners are faced with a few challenges. And here you see some emissions. These are some of the main things to address. We have the NOx and SOx emissions. They are clearly defined already in IMO, what the rules will demand from the ships. And we know it will be tight, strict things coming up in 2016 for NOx and 2015 for sulfur oxide emissions. But in addition to this, we already know that IMO is working on CO2 emissions, how to limit that. They have proposals for energy efficiency design index, or even market-based instruments can be considered there. So that is coming, and after that also particle emissions. That might be a future challenge for cruise ships, especially those operating in downtown, in cities where you have a lot of people living close by. So we need to focus on reducing the particle emission output as well. Here you see the limits for NOx emissions, and this is what is coming up in the future in Tier 3 inside emission control areas. And that you can only reach with applying a selective catalytic reduction unit to the ship or going to gas. On the sulfur side, you see that already in 2015, inside emission control areas, we will drop to 0.1% of sulfur in the fuel. And this will have a big price impact on the fuel. The cost of fuel will go up. So this will be a strategic date for it. And as you know, most of the US coastline will be emission control area, and as well European in the Baltic Sea and North Sea are emission control areas. So really for an owner building a cruise ship in the future after 2016 and will operate in some of these areas, they have three options to choose from. Either they go with the expensive marine gas oil and put a catalyst in the ship. They go with the cheaper heavy fuel, have the catalyst, but in addition they need a scrubber to take down the sulfur emissions. Or they could go for just LNG. That's the one easy solution to all of them. And that is what we have opted for in this concept. As you see here, we have a dual fuel machinery with 3 big LNG tanks in the stern of the ship located below the pool. The principle has been to make a really environmentally sound machinery. LNG dual fuel, and we have complies with the toughest sulfur emission regulation and NOx emissions. It's well proven. We have a lot of references out there, more than 1.5 million running hours on our dual fuel engines. And otherwise it's very straightforward, conventional type of machinery setup with electrical propulsion. And of course it's safe return to port. Here you see the layout of the ship. Engines divided in 2 compartments, propulsion motors as well, 2.6 L50DF and 2.8 L50DF engines. And they are running on LNG, but they also can run on marine gas oil or other diesel type fuels. As mentioned now, we have talked about LNG, so let's go through some of the benefits and features of that. The main attraction in the beginning was actually the lower emissions from LNG. We can reduce CO2 emissions, 25 to 30%, 85% reduction in NOx emissions. Sulfurs are pretty much gone because there's no sulfur when you liquefy the natural gas to LNG. And particles comes down. This will be an important feature in the future. Particle emissions will drop maybe more than 90% compared to other ships. And there will be no soot or anything coming out of the exhaust pipes that will land on the sun deck and leave nasty stains for the crew to clean up. But the other nowadays feature that makes LNG also very attractive is the price. If you look traditionally, LNG price has been between heavy fuel and marine gas oil. But now when oil prices are going up, we can actually see that LNG is becoming very cost competitive. And then if you follow the blue line, that's LNG in Japan, then we have the green line, which is natural gas in gas form in the US. And here we see a clear trend that is breaking away. And that's because of all the shale gas production that is coming up. So there is oversupply here in the US, which means that natural gas has really dropped in price and become very attractive. What we need to run on this gas is nice engines. Luckily, as Wärtsilä, we have a good portfolio, starting from 1 megawatt going up to 15, 17 megawatt of the bigger ones. And for cruise ships, probably 50 DF is the engine to choose here. And both electrical and mechanical supply is available. We also have a lot of references of existing ships running on LNG dual fuel engines. Here you see one example, a Norwegian offshore vessel designed by Wärtsilä and our Wärtsilä engines. And this is for our owner, Eidesvik, who has been very happy with the previous one. So they have bought more and more. And this is really an indication that they believe in this technology and are satisfied. But we, as Wärtsilä, we have also been pushing this for passenger vessels. And already in 2001, we did our first LNG-fueled ferry concept. And that was in 2001. And then we have continued to promote different type of LNG-fueled passenger vessels. We even did a cruise ship in 2007. And now you can say that the first order for big passenger vessel with LNG has been placed. Viking Line, as you see from this press release here, has placed an order for a cruise ferry of 60,000 gross tonnage running on LNG. And that will have Wärtsilä dual fuel engines in it. So this is really the big leap forward in passenger ship technology. The system in itself is very simple in an LNG fuel ship. You have the dual fuel engines, but in addition to that you need the tanks and some gas valve units. But otherwise it's a very simple system. The tank in itself is a pressurized vessel that has got the LNG in it, and you have no moving pumps or compressors. You just maintain the pressure inside the tank by evaporating a little bit of LNG to gas form, and that type you maintain a suitable 5 bar pressure in the tank all the time. And then you have another evaporator for turning the liquid gas to gas form before going to the engine. But basically the pressure inside the tank is feeding the gas all the way to the engine, and so on. And many people think that you need to cool down the tanks, and that is not the fact here. On the contrary, we need to heat up the tanks. So we can actually take some of the coolness of LNG to cool down the air conditioning in the ship and save some energy in that way. One of the challenges though with LNG is that you need more space demand in the ship. You see here the space of diesel as reference. The same energy content in LNG would require 1.8 times that space. But then you have these cylindrical tanks with double wall, so the compartment where you put the tank in, that will be about 4 times in space. So for the naval architect, you need to design the ship in a smart way to accommodate these tanks. In addition, there are rules really strict, putting quite strict requirements on where you can position your tanks. They are not allowed to be too close to the side or too close to the bottom. So we have done different concepts. Here you see a conventional version where we have the machinery in a cruise ferry, and then we have put the tanks in front of the machinery in the normal way. We have also designed a cruise ship where we did another approach. Here we put the tanks up in the superstructure in front of the engine casing with free access to the air above. And this is a very safe and good position. Of course, it requires a little bit better stability in the vessel. Or you could put the decks on the aft deck outdoors. And this is one approach that we have suggested for some owners. And actually, if you look at the Viking Line ship, this is where you will find the tank. So they have opted for this solution. But in this handy-sized cruise ship, we have gone for a new position. Now we have located the tanks below the pool deck in the stern of the vessel. And it's a good location. It's not under the superstructure, it's after it. You can arrange access to the compartment from outdoors, which is required by the rules, and so on. So it's a nice thing. The capacity of the tanks is 1,400 cubic meters almost, and this would allow a cruise range of about 12 days, plus some margin. But you also need to bring the fuel to the ship, and this is one of the tricky questions, of course, today. You need to have a distribution system for the LNG, and that is one area where we are working today. Some ships, the smaller ones, can bunker just from a truck That's easy to put up and so on. But now we need so big volumes, and most likely we need a bunker barge or something else to bring the fuel to the ship side. And here you see one of our designs for a LNG bunker barge. But you could also think of more innovative solutions of bringing LNG to a ship. Here we have a barge carrier that would carry LNG barges to a port, and then it ballasts down and replaces, brings a full LNG barge and then takes on an empty one and takes it to the LNG terminal for filling up. So this is this kind of bottle recycling system that you could have. And then this kind of barges, they would bunker the cruise ship from the stern in this case. So this is a good area, far away from the superstructure, no balconies or anything close by. In order to a little bit highlight the benefit of this machinery concept, we have made a comparison. So we have compared the standard machinery, as I shown before, running on LNG with the 4 dual fuel engines, to a machinery running on marine gas oil with SCR units, but normal diesel engines. And then the third option is heavy fuel, diesel engines, SCRs, and a scrubber to take down the sulfur emissions. Here you see a scrubber. This is also one of Wärtsilä's products that we are currently supplying to the marine market. So with this we can take down the emissions as well. We have applied the operating profile and then assumed some fuel prices. We have taken the price of fuel in Houston from last week, and then we have assumed an LNG price of $13 per MBTU. That is our very conservative assumption what LNG might cost for a cruise ship. The market price in natural gas in the US is less than $5 per MBTU today. And so this gives quite a lot of margin to be able to supply it to a ship, and that's what we wanted not to give a too positive view of this. We applied a very conservative approach to the price. But when using these prices and profiles and machinery concept, you can compare here the energy consumption in orange and the fuel cost in gray. And compared to marine gas oil, we cut the fuel cost in half. Compared to heavy fuel, it's a significant drop as well, more than 25% down in fuel cost. Here you see then when you add all the other consumables for the machinery. So you have fuel and lube oil, but then you have, in this case, you also need urea, and for the scrubber you also need caustic soda and some other chemicals in the ship that will add cost. So here you see that basically you can virtually cut the price in half. Unfortunately, of course, LNG machinery costs some extra. We have more expensive engines, the dual fuel type. We need the LNG tanks, but in addition to this, we also need a bigger ship. So we have some extra cost for a bigger ship to accommodate these tanks. So you can say the price difference is maybe 10 million between today's vessel and that. Heavy fuel, somewhere a little bit more expensive because you need the scrubber in the future. But when you calculate this on 10 years and annual payments, then you can say that LNG still is more economical. But more interesting, if you calculate net present value, marine gas oil is referenced with LNG on 10 years. This is, it's not said here, but it's 10 years operation. It's 45 million euro that you can save by operating on LNG. That's the advantage. And this is then already including all the more expensive ship has been included in these calculations. And compared to heavy fuel, it's 26 million. So there is clear economical reason to consider LNG as a fuel in the future. And emission-wise, you can also reduce emissions here, both CO2 and SOx emissions. All these machineries comply with the IMO Tier 3 regulations for NOx emissions. On the propulsion side, we have selected just a quite conventional setup in this case. We have shaft lines with, but to improve efficiency, we have put on our Energopack rudder. Here you see a model of it. It's basically a special hub and then the rudder with this kind of torpedo shape there. And this will improve efficiency 2 to 9% depending on ship type. In a cruise ship, it's probably more in the 2 to 3, 4% range. And then higher numbers are for full-bodied single skeg vessels. And the advantage with this is that we can really reduce the hub drag of the propeller when we stream. Here you see a conventional solution on all the turbulence and drag behind the hub, and here you see the better flow we get with this torpedo shape. There are other options to this conventional shaft line. We could think of a wing thruster setup where we could get better efficiency, or we could, here you see the machinery of that, or we could think of just a triple screw solution as well, where we, inside the center skeg that we anyway have in the ship, we position a third shaft with an energy recovery device behind it. And here we say we can save maybe 6% in this. Payback is 5 years, and so on. And also this would give better maneuvering thanks to the fact that we have 2 rudders generating side thrust while one propeller is reversing. In a conventional ship, if you're maneuvering and standing still, just one rudder is generating side thrust. So we also today want to go more looking at the life cycle approach to cruise ship, and there we see that we can offer a lot in added benefit. We can do maintenance agreements, we can do dynamic maintenance as we call it, which is based on condition-based maintenance system where we only exchange parts when they are really needed. And we can improve reliability. And this allows us to keep a quite moderate power level in the ship, since we can get better reliability and availability from the machinery this way. But really, to sum up my presentation, I would like to conclude with some remark. Handy-sized cruise ship concept, we believe, can be an interesting type of vessel in the future, but especially LNG, it offers clear economical benefits. Net present value compared to heavy fuel, 25 million, and marine gas oil, 45 million for 10 years. That's clear money. Payback 1.3 years, and you get the lower emissions. So it's a real benefit there. And this is no future technology. This is based on well-proven and reliable engines and technology that we have in the ship. A little bit food for thought. When the oil crisis hit in 1970, who wanted really to be the last one having a steam ship that would burn a lot of fuel? And who really wants to be the last ship owner to rely only on oil-based fuel in the future? So with that, I would like to thank you for your attention. And if there are any questions, please ask away now. I'm here to answer them. Thank you.